evening, Northern Colorado. This is Kilo Delta Zero Tango Yankee Uniform Joe here in Loveland. I am net control for tonight's TechNet, sponsored by the Northern Colorado Amateur Radio Club Net. We are taking check-ins to find out who's here. Just call now. Nobody's here yet. Again, we're looking for check-ins for TechNet. Please call.
Hey, Joe. Whiskey Zero, Delta Delta Zulu, Dave and Greeley.
Got you, Dave. There was somebody else that doubled with you. Come back.
My bad. W2MIC. Mark in Loveland with 1.5 squirrels.
I got to hear the story about the half.
I've caught a great big one, who I think is Mom, and there's a little one hanging around, and every time the little one comes over by the big one in the cage, the big one in the cage gets really distressed. So I think I'm looking at, I've caught Mom, I've got my second trap out for the kid, and if I don't get the kid within next hour or two, I'm going to let Mom go, because what's the saying? She'll make more.
Very good, Mark. Well, I thank you very much for that. I appreciate that. Anybody else want to check in for tonight's TechNet, please call.
This is KE0 Oscar X-Ray Victor Scott in Fort Collins.
Hey, Scott, what's up?
Hey, it's kind of chilly out here, Joe. But they say the rest of the week's going to be in the 70s, so I guess there's hope.
Yep, I think we're good to go. Well, thanks, Scott, for checking in. This is KD0TYU looking for check-ins for the Northern Colorado Amateur Radio Club sponsored TechNet. Please call.
This is Kilo 1 Delta Echo Golf.
Hey, Mike.
Hello, Joe. We're just sitting here at the desk playing with some hard drives.
I've done lots of them. Have fun. Anyone else want to check in for tonight's TechNet, please call.
Good evening, Northern Colorado. This is Kilo 0 Delta Bravo Echo, Debbie in Fort Collins with November 0 Echo Mike Papa, Greg.
Good evening, Debbie and Greg. Thank you very much for checking in. Anyone else want to check in for TechNet, please call.
Is
Kilo Alpha 6 Echo Tango Echo, Jim in Loveland.
That's Jim, but actually you doubled with somebody. Come back. I think it was Luann. Is that right?
ding ding. Yep, it's Kilo 0 Lima Alpha Oscar with Kilo 0 Papa Romeo Bravo.
Good evening, folks. I thought I caught you there. Thank you very much for checking in. Anyone else want to check in for tonight's TechNet, please call.
Kilo Charlie 0 Quebec Oscar Kilo Marty Wellington.
Mike, George and Berthoud.
We had kind of a semi-double. I got part of it in that. Let's go to KC0 and then give me the rest of the call and your name. I'm sorry. We had a double right in the middle of that.
Quebec Oscar Kilo Marty.
I got you, Marty. No problem there. And whoever was doubling with Marty, come back.
Alpha Echo 0 Golf Mike, George and Berthoud.
I got you, George. Thanks so much for checking in. Anyone else want to check in, please call.
KW5 USA, Jason Loveland.
I got you, Jason. KW5. What was it? KW5 what?
Uniform Sierra Alpha.
Oh, USA. Easy. Thanks, Jason. Anyone else want to check in? Please call.
Kilo Echo Zero, Mike India Zulu, KE0MIZ, Rob, Owl Canyon.
Evening, Rob. Anyone else want to check in?
Kilo Echo, Farm Foxtrot Juliet, Tim Bellevue.
Tim Bellevue, very good. Anyone else?
Kilo Echo Zero, Papa Tango Echo, Mike in Fort Collins, no traffic.
Who knows, Mike? You might have a way to solve one of our problems tonight. Thank you much for checking in. Anyone else?
Echo Zero, Charlie Foxtrot, Ben, Fort Collins.
Alpha Charlie Zero, come back with your call. I'm sorry, is this Ben?
Yes, it is. Alpha Echo Zero, Charlie Foxtrot.
I'm sorry, the phone rang and I looked up and that's all I had. Thank you, Ben. I thought it was you. Anyone else?
November Whiskey Zero Uniform, Ron, Fort Collins.
Ron, I don't know if it was my radio or yours, but you're a little statically. I just got the name. Would you come back with your call, please?
November Whiskey Zero Uniform.
Not at that time. Thank you, Ron, for checking in. Anyone else? This is KD0TYU looking for check-ins for the TechNet. If you'd like to check in, please call. Hey, looks like we've got a good bunch here. Before we start out, does anybody have any comments, questions, or anything they'd like to talk about? Please call. Well, that sure set the crickets going. Anyway, my topic for tonight is something that I've had a lot of people ask the questions. Okay, we got the antenna from last week. Well, we didn't get the antenna, but got the antenna. I got my radio. Now, how do I hook those two together? What we're talking about is the basic coax, or whatever you want to call it, the power line going out to the thing. Let's start out with UHF, VHF, and then work our way up. Mark, do you have any comments on what you would use for a good UHF, VHF system? W2MIC.
W2MIC, I do indeed. I am a great fan of LMR, Lima Mike Romeo 400. It is a wonderful, very robust coax. The bad news is it costs about $1 a foot. It is very low in loss. It is highly suitable for both VHF and UHF. It will also very handily handle, oh boy, HF. So I tend to use it for everything, because no matter what I do with a coil of coax, the next week I'm going to need it for something else. So I get just the one kind, and that lets me use it with HF, VHF, 6 meters, UHF, 220, whatever. It is certainly possible to go with less expensive cable like RG8X, that's Romeo Golf 8 X-ray, if you're doing only HF.
you done, or were you just waiting for the repeater to drop?
Let's see. The suggested connectors are the SO238. SO stands for socket, by the way. Also sometimes called the SO239. And the opposite is the PL259. That's PL for plug. You don't really need N-type connectors, N is in November, for HF, and it's arguable for VHF and UHF. It's certainly not a bad thing, but they're very expensive and very inconvenient. If you're moving up towards 1.2 gigahertz, then you certainly do need N-November type connectors, and that's back to that.
I guess I have a question, and I've never worked with N connectors. Be honest with you, I really haven't. Everything I've done is pretty much on 259s and 239s. Are there any? You say they're more costly. Like how much difference?
Oh, in terms of a bare connector, probably 3 or 4x as much. The other issue is you can order almost all modern radios from the factory with N-type connectors. And there's a very good argument that the UHF connectors, the SO238, 239, and the PL259, are not 50 ohms. The N-type connectors are. So if you're running higher power, an N-type connector is a very good idea because you're not dealing with minor reflections. Ordering the N-type connectors from the factory, and HRO does stock some, is typically $50 to $100 more than the radio with the UHF, VHF connectors.
Is the installation of the N connector any different as far as a crimp-on? And again, I know nothing about N connectors, I'll have to be honest with you. Compared to like a 259 or the 239s?
Very similar. If you can do one type, you can do the other. If Kerry N0WIQ is on, he is a great fan of N connectors and even goes to the trouble of removing the UHF connectors from the backs of his radios and replacing them with N-type connectors.
Anybody else have any comments about that? Come back. Dave W0DDZ, what's your comments on this?
I'm sorry, Joe. I was working on something. What was your question?
Well, we're talking about LM400 and N connectors versus PL259s and SO239s. Which would you recommend?
I mean, so most of the radios I've used have been PLS 259 SO239, so I have used that and had more experience with that. I'd have to probably go with that one just because all of my equipment is that way. I guess you could get the antenna spec for like an N connector, and that might work for like a mounting situation in a mobile application. But most of the radios I've seen have the PL239 and the SO259 on the actual radio.
Bro. Go ahead, sir.
Yeah, it's W0LEV, and Mark is right. SO239, PL259 are just fine for HF. However, be aware they are not an impedance control connector. You may find the dielectric in the things. I've experienced probably as many as 5 different kinds of plastic, all of which have different epsilon R. They're not impedance controlled. Most of them don't come out to be 50 ohms. That becomes an issue on 450 because they are approaching a significant portion of a wavelength on 450. Personally, I don't like them. I do like type N's, which are very good on 1296, 2304, so on. All my radios at 100 watt level that have the SO239 on the back, I screw a SO239 to BNC adapter, and all the 100 watt stuff is done with BNCs. From there on, take a choice, but on 450, yeah, you ought to be using type N, W0LEV.
Thanks for those comments, Dave. Now I have a question for anybody who wants to answer this. Is all LM R400 all the same, or are there different levels in this as far as, you know, if you buy it for 50 cents a foot, are you getting the same thing that another guy's paying $2 for?
MIC.
Go ahead, Mark.
Very cogent question. There are several different flavors of LMR 400. In particular, there is LMR 400 Flex, as in highly flexible, has a 1-inch bend radius. And then there are several different companies, I'm thinking specifically of DX Engineering here, who have made under contract their own approximate equivalent of LMR 400, which they call something or another 400. You have to look at the spec sheet very carefully. There are subtle differences, and yes, there are different types of LMR 400. There are also many different types of LMR in general, 200, etc. But amongst the LMR 400 family, and I believe there are 4 different kinds, just that's off the top of my head, they do have slightly different loss levels for long distance. So you do want to look carefully if you're running UHF for 450, as Dave says, or anything into the 1.2 gigahertz and up.
Well, now that brings up a good question. Back when I was a rookie, which was probably the day before yesterday, I noticed that there was a difference in frequencies as far as loss goes for lines. Why is that? Why is that? Why is that?
W2MIC. Well, we'll get W0LEV to chime in on that, but speaking as an electrical engineer, different kinds of coaxes are manufactured with different materials, stranded interconductors versus solid, and they are built with different kinds of external shielding, which might be foil or might be braid, and the braid might be very tight, which is of course expensive because it uses more copper, and a tighter weave braid, something like 95% coverage, will be mostly sealing off the outside world electrically. Whereas inexpensive cable, and I'm thinking here of what Radio Shack used to sell, will have something as low as a 50% braid or a 30% braid, which means 70% of the cable is exposed to the outside world, and your signal is leaking and other stuff is coming in. Third, the dielectric, in other words, the plastic or the foam spacer between the central conductor and the outer braid, may be very different in material, very different in cost, and very different in behavior and performance. So basically, expensive cable works really well and cheap cable is junk, and everything in between is available. So what you have to look at is, number one, what is the loss per 100 meters at the frequency you're interested in? Number two, what is the braid coverage? And even if the loss levels look pretty good, if the braid coverage is low, you'll be picking up noise from other sources like marijuana grow lights, growl, snarl. Really good cable will have two shields, one outside the other. And it's too bad that W0ASP isn't here. He's over in South Korea, I believe, because he has lots of experience with shielded and double shielded cables. Let's see, back to net and probably over to Dave, I suggest.
Yeah, okay.
Go ahead, Dave.
Just wanted to get permission from net control there. Mark has covered most of the material, but a lot of the companies today, for the less expensive coax, will use braid to the tune of 30 to 40% coverage and make up for that with foil over coverage. Problem is, to get any physical strength for the very thin foil, it's backed with mylar or some other flexible plastic, and it may or may not make contact with the braid itself. Also, there are various ways of applying that very thin foil. You may have there's spiral. There is it's continuous coverage where they fold it over, but because of the plastic, the fold and the contact portions of the spiral may not contact electrically. Bottom line is, spend a little more money. If you put up a good antenna, don't waste it with cheap cable. Spend a little money on the cable. It's worth it.
Zero EMP. Greg, I know you're out there. Please come chime in.
Evening, Joe, and Zero EMP. As has already been mentioned, loss in coax is in loss per. It goes up with frequency, so at HF you'll have a certain level of loss for any brand of cable. VHF will be higher, and as you go up into 70 centimeters and higher, it increases sometimes dramatically. And that loss is per foot or per 100 feet of length. So not only the cable is a consideration, but how long your run is going to be and how much loss you can tolerate. So if you're doing a mobile install and you're going to run 12 feet of cable and you're only going to be hitting the local repeaters with your mobile, and of course you're going to be receiving the 80 to 100 watt outputs from the repeaters, you can tolerate a lot of loss, and you can use something like RG58 even for UHF, and you can use the PL239, 259 connectors, and you'll never notice the difference. If you are running 50 feet up a tower that's 100 feet away from your station, and you're running 150 feet of cable, and you're going to be doing weak signal work on 70 centimeters, then you want the best connectors and the best cable you can afford. So you need to figure out how long your run's going to be, what you can tolerate for loss, and what frequencies you're going to be working and what kind of power levels. Loss is two ways. Loss is losing transmit power on transmit and receive signal on receive. And then, of course, the shielding they talked about is important also for keeping noise out, especially if you're doing weak signal. And zero EMP.
Comment, LEV.
Go ahead, Dave.
Yeah, for the newbies, the loss per 100, it's usually loss per 100 feet. You don't get loss per foot until you get up into the microwave region, and we use more exotic coax up there. It's expressed as dB per 100 feet as a function of frequency. Just remember, 3 dB is half power, and that's both directions, like Greg commented, both receive and transmit. So if you're transmitting 100 watts at 100 feet, you only get 50 watts at the antenna. 6 dB loss is, well, pretty miserable. Quarter power. Just the larger numbers, unlike everything else in this country, are worse, not better. 3 dB is half power. Just kind of keep that in mind, because all of the tables are dB per 100 feet or dB per foot. W0LEV.
Well, since we have a lot of new folks on here, and we have an awful lot of experts in here, I kind of want to define. There's tables all over the website for this type of situation that we're talking about. But I brought up a table here that kind of emphasizes what this is. So I'm going to ask these questions. If I'm running 8X, the cheapest cable you can buy, okay? Like you can probably buy 100 foot for $10 or something like that. I'm guessing. I don't know that for a fact, but I'm guessing. If I'm running 40 meters, I got hardly any loss at all. But the minute I turn around and go on 2 meters, I got 4 times, or actually it's 4.2 dB loss for 100 feet. Why is that?
Increased frequency, as has been commented in the past here, loss increases with frequency for a given coaxial cable. I think we've already discussed the reasons why there's loss in the cable. Mark did a pretty good job there. Again, you put up a good antenna, don't waste it with cheap coax.
MIC.
Go ahead, Mark.
And it's important to realize that 4-point-something dB loss, you're actually heating up the cable. So it is possible at high power levels to melt crummy cable and or convince it to catch fire, literally. The impedance of the cable at frequency is a function of materials, and the low resistance at frequency materials, low impedance at higher frequency materials are quite expensive. So if you're running from a few pennies a foot up to $1 a foot, yeah, that's a big difference. And the other side note is, if you're running 50 feet out to your tower, 100 feet out to your tower and 50 feet up your tower, you're going to lose a lot in your cable, and then hopefully you're going to have some gain in your antenna. But if your run is too far, or if the cable you are using is too lossy, it is absolutely possible to not be able to get there from here. In other words, you can't get enough power into the cable to go down the cable, to be lost in the cable, heating up the cable, to get up the tower to the antenna to get some gain benefit from the antenna. So you have to count the whole system, not just the cable.
And that works for both receive and transmit.
Okay, so I guess what we're saying is, let's go back to that example of using the 8X on, say, 2 meters or even 40 on 70 centimeters. It's worse. Okay, but that accounts for receive too. I guess I didn't know that.
Losses both directions. So if you want to do a total budget, you lose twice between transmit and receive. If it's rated a 3 dB loss, you're really losing 6 dB if you include receive. It's 3 dB on transmit and 3 dB on receive. Yeah, okay. But in RG8X, yeah, it's all right for HF, but when you get to VHF, UHF, it actually is worse than a lot of less expensive cables.
Mind you, I'm a very, very big advocate on Davis Berry Flex and LM400 or LMR 400. Sorry, I use it for just about everything. In fact, I actually bought a new crimp kit, and I've used jumpers on some small stuff where I'm using 8X, and they're going to go to 400 as of tomorrow. So I totally agree with you guys. It's just easier to start out that way than it is to screw it up. Jim, KA6ETE, do you have any comments?
Yeah, I'm right with everyone else. In fact, I got kind of lucky. A good friend of mine works for a tower company that did a whole bunch of work last year and replaced a whole bunch of antennas, and whenever they ordered the antennas, they got all new cabling, and the owner of the tower did not want to put the new cabling in. He said throw it away, so I ended up getting 500 feet of LMR 400 for free. But that's everything I use. External is all LMR 400. Inside for short jumpers, and that just for flexibility, I have the LMR 240 to go from my antenna switches to the radio itself. I mean, they're just short 3 to 5 foot jumpers.
K1DEG, Mike, do you have any comments about this? I guess Mike's left the building. Now, I got to bring up this because I've heard a lot of controversy about this. The solder versus crimp-on cables. Let's go around the horn and say, Jim, let's start there, KA6ETE. What is your preference?
My preference for at home, or if it's a permanent install, I always like solder connections. When I'm out in the field for quick repairs and that, I have a crimp set that I use. But I always like to default whenever I have more time to solder everything correctly. It just seems to hold together better, and it seals a lot better. With that, and wrapping everything with the coax wrap and shrink tube to get a good weather-tight seal on it.
I know that Greg does a lot of this. Mr. EMP, what's your comments?
Before I answer that, there's a couple quick things that we've kind of touched on. There are some coaxes that are rated for direct burial. So if you're going to bury it directly in the dirt, you want one that's rated for direct burial. The other thing ETE just touched on is moisture and weather sealing. No matter what your coax is, if water gets under the jacket, your loss is going to go through the roof. So you got to keep it dry. You got to weatherproof your outside connections and make sure water doesn't ingress into it at all. And if you ever have an installed cable and you notice your SWR going through the roof, put a dummy load on the far end, and if it's still bad, more likely than not, the jacket or a connector leaked or got punctured and water got in. So that's that. As far as solder versus crimp, when I put on my own PL259s, I solder them. When I have LMR 400 cables made for me on a custom length, I have them made by a company here in town, which I'm totally drawing a blank on. It's up north Fort Collins. Anyway, they have the right crimp tools to do crimp connectors, and they've worked just fine for me.
Anybody else have any comments? Go ahead.
Yeah, I'll make it quick and succinct. Crimping is to hold stuff in place so you can solder it. W0LEV.
MIC.
Go ahead, Mark.
Same. Crimping is to hold things in place so that you can solder them. Solder only, always.
I've done a lot of research on this. I've done a little research on it, I guess you could say. YouTube videos and various other things, and I realize that YouTube videos are very biased to whatever the person has. And they always say that if you are going to crimp it, you don't crimp the center connector. You actually solder that, and then you would crimp the braid around that. Mark, you think you just ought to solder it all, correct?
Correct. Solder the interconnector and solder the braid.
Other comments about that? You know, I've got a question that I really don't understand, I'll be honest with you. When we first started getting into this, everybody talked ladder line. And I was under the understanding there is so much problems with ladder line as far as going through things or getting by. If you got it by a metal surface, it doesn't work. Mark, let's start with you. What do you think of ladder line?
I have some experience with ladder line in the ZS6BKW. I think that's the correct term. It is a antenna that works very well on most bands with no tuner, no transmatch. Ladder line is two wires running in parallel, held at a constant distance by some kind of structure. Most commonly these days it's called window line. Old TV twin lead is another kind of ladder line. The old ladder line consisted of wires stretched between poles wrapped around glass conductors, and this was like 100 years ago. Ladder line is absolutely wonderful stuff because it's low impedance and it doesn't care about bad or mismatched SWR. The reason we've mostly moved away from ladder line in all industries is Coax is shielded. You can put the signal down the conductor in the center of the coaxial line, and then the braid protects that signal from outside interference. And that means you can run coax underground, you can run it underwater, you can run it, in tight curves, you can run it through metal surfaces, you can run it along metal surfaces. Ladder line will not tolerate any of that because the two wires are just hanging out there. They're insulated, electrically speaking, so you can touch it, but they're not shielded from other interference, so incoming signals will get onto the ladder line. The ladder line will interact with anything that's conductive, so a metal building, an aluminum building, a tree, because trees are full of water going up to the leaves. Ladder line does not like being buried. It's finicky stuff. It's absolutely wonderful if you can keep it away from everything, and if you can stand up to the wind load, because ladder line likes to flap in the wind and tear itself apart. Back to Net.
Dave, LEV, what's your comments about ladder line?
Mark did a good summary, but I do have a few comments. I use it, open wire, just about exclusively on the feed for my HF wires. And yeah, you got to treat it properly. It's not any good near conducting surfaces. But there is a belief amongst amateurs that because the wires are exposed and not, quote, shielded, unquote, they're wide open to interference. Properly deployed, properly treated at both ends, that's totally false. Ladder line is great for differential sources and loads, like a dipole. Typically, like a beam if it uses a dipole feed. You have to maintain that balance, 0 and 180 degree phase between the wires. As such, here in the shack, the first thing the ladder line sees is a common mode choke, which discourages common mode energy, which, if you have local interference sources, will eliminate the line on the way from the antenna to your shack with common mode energy. The common mode choke gets rid of that. You have to treat ladder line properly. It's not coax, but if it's treated properly, it's absolutely wonderful. Low loss, it will support high SWR with relatively low, far less loss than SWR in a coaxial line. I've used it, and also another piece of snake oil that goes around amateur circles is if it gets wet, it's garbage. Not true. I've been using the stuff for HF for, since we've been in Colorado. That's been 1995, and down in Albuquerque for 15 years, so go figure, 25, that's 35, 40 years. I have never seen a major readjustment of the antenna matching network due to heavy rain. It can get wet. It just really doesn't care too much. No, you can't immerse it in water, but a good heavy rain, good snow, even ice storms, icing the stuff up. Yes, there's a minor change in its transformative impedance, but it's really totally overrated. It's wonderful stuff in my book. W0LEV.
Dave, I do have another question since you have it. Kerry and I were talking originally a long time ago, and he likes ladder line, but he says you have to be very careful how you bring it into the house. What's special as far as going through walls and various things like that? What special do you use?
Well, the last two houses, the one that burned and the one we're in presently, I had them leave any metallic structures for a foot around away from where it was going to come through the wall. One in the garage and one between the garage and the radio room here. I had a say about how the house was constructed in that respect, and it works. In Albuquerque, I didn't have a lot of say. The house was already there. We had hardware cloth so they could put stucco on it. That's standard finish in Albuquerque. And I just drilled through the stuff. I didn't go to any length to try and clean out the hardware cloth. And I used porcelain insulators, long porcelain insulators, to feed the wire through the wall from the outside into the radio room. And yeah, I'll confess, the drill pretty much cleaned out the hardware cloth between the conductors, but there was no other action taken in that respect. And it worked just fine. If you talk to WD1W, who has, let me reset here. When he was in Vermont, he buried the stuff. You know, against all engineering best practices of using parallel transmission line, it worked for him. Now, worked is a relative figure of speech when it comes to how well an antenna and feed line work. I prefer to play it through a good model on a computer before I say it's going to work or isn't going to work. Propagation is too variable to judge unless you're judging it over a decade period. Anyhow, enough of that. Oh, I wandered maybe where I wasn't supposed to, but those are my comments. W0LEV.
I thank you for that, because this has been one thing I've never tried. No, I'm curious, and please, if anybody else has got any questions, in fact, let's go out there. Has anybody got any comments or questions about this? Please call now. Greg, EMP, you've worked with lateral line, haven't you?
I have, Joe. My current HF antenna uses it. It's a full-size 80-meter loop, horizontal loop, and on that type of antenna, it'll tune on all bands from, in my case, 80 meters on up, so 80, 60, 40, 20, 10, 6, everything else in there. But there's going to be some wild SWR swings in there. And like has been mentioned with Coax, if you get a big SWR mismatch, you get a lot more loss. Ladder line, you don't. So what I did is I have about 50 feet of ladder line outside that brings that antenna feed right to the outside wall outside my shack. The tuner I use needs Coax input. It's not a ladder line tuner, so I need to use a matching transformer. I use a 4-to-1 because it gets the impedance kind of in the neighborhood of where I want to be. So 50 feet of ladder line outside, kept away from everything metal. And I mounted my matching transformer in a weatherproof box on the outside wall. So the ladder line runs to there, and then there's the matching transformer that kind of gets it somewhere near 50 ohms. And then I only have about 6 feet of Coax, good LMR 400. I only have about 6 feet of Coax that comes through the floor, because there's a bump out there, so it comes up through the floor and into the shack and to the tuner. So I minimized how much Coax run I had on the setup by doing it that way, and it works great. If you look at those loss tables we talked about, go all the way up to 1296 megahertz if you want, and look at what the loss is on ladder line compared to even expensive Coax, and then look at how much ladder line, how cheap it is, and you'll see why, if you can use it, it's a really good option, and zero EMP.
This is KD0TYU with the TechNet. 2 questions for you, Greg. You say it's less expensive than Coax, and the second thing is, what is the impedance on ladder line?
There are different widths of ladder line. The stuff I use is about 1 inch wide, and that's 450 ohm. The more space between the 2 wires, the higher the impedance. There's 600 ohm line. But the thing with ladder line is you can have a huge mismatch, and it doesn't matter because, in my case, on my antenna, since I use it over the whole HF spectrum, the impedance is all over the place anyway. So I can use ladder line for that outside feed and not care what the impedance is, and then transform it down to something around 50 ohms for the short Coax run. But wireman.com, I guess it's going to be, it's a retailer, sells lots of great antenna wire and stuff. They sell ladder line. Take a look at their 450 ohm. I use what's called window line. It has cutouts in it. I use their 450 ohm window line, and it's very tough stuff, holds up very well outside. Look at the loss per 100 feet at UHF and look at the cost per 100 foot and compare that to LMR 400.
That comment.
Go ahead, Dave. You have the floor.
Yeah, Greg pretty much hit it, and he almost went by an important point. He did make the comment. The impedance of the line really doesn't matter. You can find it anywhere from nominally 600 to 75 ohm for TV applications. The impedance doesn't matter because you're going to take that out in a matching network in a shack. I have the ladder line on HF hits a common mode choke, goes into a twin T matching network, and it is not an antenna tuner. It does not tune the antenna. It's a matching network. Twin T matching network comes out through another common mode choke and then in the coax. And again, I don't have any more than 5-6 feet of coax in the whole system.
Interesting. Yeah, I'd heard that there's a lot of advantages to have it, and there's a little bit of disadvantage because you have to treat it a lot different than you do coax, where you just kind of put it in and hope for the best. Any other comments or questions about this?
MIC.
Right ahead, Mark. You have the floor.
W2 MIC. I want to leap back to earlier in the discussion when Dave was talking about losses in the coax for receive. And we're looking at, I want to run 50 feet out, or 100 feet up to my tower and 50 feet up, and I want to be listening on UHF. It's critical to understand that high-gain receivers in radios, good high-gain receivers in radios, are extremely expensive. Far, far more expensive than the price to upgrade from any old coax to good LMR 400. So as you're looking at the system, which is your radio, your transmatch, your transmitter match, your transmission line, which might be coax or might be ladder line, and your antenna, it is critical to think about the idea that an incoming signal can be gobbled up in the coax due to line loss before it gets to your radio, and there's almost nothing you can do at the radio to recover it.
EMP.
Isn't anything you can do. If you've got 3 dB of loss between the antenna and the receiver, there's nothing you can do with the receiver to get rid of that 3 dB loss. Most of us who run weak signal will mount a preamp up at the antenna feed. Enough gain and low enough noise figure that will just about, pretty much overcomes the coaxial loss on receive. But it gets pretty complicated because you got to have a relay up there that will withstand the power, and the relay that has to offer enough isolation between the input of the preamp so you don't burn it out when it's in transmit. That's about the only thing you can do to overcome coaxial loss on a long run. W0LED.
Go ahead, Greg.
Yep, LEV stole my thunder exactly. There are preamplifiers for receive, and the correct place to put the preamp is at the antenna, not down at the other end of the coax run, because once it's gone, it's gone. If you've lost that signal like it's down below the noise floor, it's gone. So the preamp goes up at the antenna, and they make preamps, and this is going to be for UHF or even VHF. You're not going to do this on HF. You're not going to have to. But the preamp normally is powered through the coax. So in your shack, there's an adapter that hooks onto the coax to put DC on the center conductor to power the preamp. And there's receive-only preamps if all you do is listen. But if you're at ham and you want to transmit, they do make preamps that automatically detect the transmit RF when you key the mic, and they switch over. They cut themselves out of the circuit so you can transmit, and it passes the power through to your antenna, and it does not destroy the preamp. So there is that option. Let me reset here. The other option you have, more and more of our modern radios are capable of remote operation, either through a detachable faceplate and a interface cable, or through computer software. And if you're working weak signal, UHF, or microwave, and you're looking at the cost of really good coax and how much you're going to need for your installation, at some point it becomes economical to consider putting the transceiver at the antenna up on the tower, or in a weatherproof enclosure just below the rotor if you have a beam and a rotor, and have a very short length of coax, a few feet, and run your transceiver remotely. That's something when you, depending on what your install is going to be, it can become economical to do it that way. Of course, then there's other things like lightning protection and stuff you have to worry about, but that's all part of the planning. But that's an option, and 0 EMP.
Another comment.
Go ahead, Dave. You have the floor.
Yeah, Greg, I'm not going to put my nice new fancy IC7300 out there in the weather. I don't care how good. I just couldn't do that. But it's an option. I want to bring up an article, and I don't remember how long ago it was. It was within the last 5 years, I'm relatively sure. QST ran a cute article on just these issues. Return on investment, and determine what you want to do against what you want to pay for. And it was a pretty good article. I mean, I've been a ham too long, but it was a good article for newbies especially. All of us are on a budget. Well, most of us are on a budget. Being retired is a super budget, but we won't go there. Consider the return on investment and what you want out of your station. W0LEV.
Other comments, questions? Call now.
MIC.
You have the floor, Mark. Go ahead.
You know, all these spreadsheets and analyses that I have done, expensive low-loss cable is always the least expensive way in the system cost to get good transmission and good reception. So you can put that tower up, and you can put a great big expensive antenna on top of the tower with a rotator, etc. You can buy really, really good radios with really good receive sections. You can put preamps up, and then all of the assorted headaches that go with them, like control, lightning protection, etc. In all of the ways I've looked at systems, it's the coax that's the least expensive way, and yes, I buy $1 a foot coax. It's the least expensive way to get the gain of the system or to minimize the losses in the system.
Any other comments?
Mark is saying is penny wise and pound foolish. It's worth paying a little extra for good transmission line. W0LEV.
Well, I guess it all depends how many times you want to put it up there. You know, there's that. There's the guys that really like to get up there and do it every other month, and then there's the guys like me that wants it up there for years.
Yeah, and if you should stumble onto 100 feet of 7/8 coax that is used professionally, don't waste it on HF.
You know, surprisingly enough, occasionally we do. We'll get somebody on here that has a bunch of that, or hardline or something like that, and don't know what to do with it. So we definitely keep our eyes open, but I don't want it.
No, connectors are too expensive.
Yeah, I've heard that those are expensive, and they're really hard to find somebody that knows what they're doing to put them together.
N0 EMP.
Go ahead, Greg.
W0 LEV. I need to go to supper.
N0 EMP. There's another way around this, on especially UHF and microwave. There are devices known as transverters. It's an up converter and a down converter. And I have one for 1.2 gigahertz, and the input, it takes a 2 meter signal going in, and then up converts it and transmits it. And when it receives, it takes that 1.2 gigahertz signal and it down converts it to 2 meters and spits it out back to my rig. And it works with a regular sideband receiver like a TS2000 or something. If you use that, you can mount that, and a transverter is a small thing you can put in a weatherproof box. And they have them for all the different microwave bands, and they even have them for 70 centimeter and 2 meter, and they had them for 6 meters way back when there weren't a lot of 6 meter rigs around. In the 50s, they had transverters for 6 meters. But if you use a transverter, you can mount the transverter at the antenna up on the tower, and then your coax isn't carrying that UHF or microwave signal anymore. It's carrying a 2 meter signal where you'll have a lot less loss for whatever kind of cable you're using. N0 EMP.
Good. Thanks for that, Greg. Any other comments, questions? Well, this has been an enlightening night. I appreciate that, literally. We have a guest here tonight, K86ETE, Jim, who is going to take over the TechNet as of next week. I'd like to thank him very much for volunteering for this, and I wish him all the luck in the world, and of course we will be there to support you if needed. So if there's no other questions or comments for the net, this is KD0TYU going to be clear. Everybody have a pleasant evening. Great net.
Thank you for watching, and don't forget to like and subscribe.